Water, it's liquid gold in the southwest part of the United States. And in our world, H2O is the element most important to life. Water for drinking, agricultural irrigation, manufacturing, power generation, wildlife conservation, protection of the environment, and recreation. It doesn't take a rocket scientist to realize that without water, life itself would not be possible. Yet, water is something we all seem to take for granted. We turn on the tap, and it's there, seemingly in abundance. But what if we turned that handle one day and nothing came out? Hi, I'm Jack Strickland, and I live in the town of Payson, Arizona. This is one of the most beautiful areas you'll ever set eyes on. I enjoy the quality of my life here, and that's why I became concerned about our water situation in Payson. Water is the most common substance on Earth, collecting in lakes and flowing across the land as streams and rivers. Water is plentiful, and yet only 1% of the water on Earth is available as a drinking water source. 50% of the U.S. population, including all of us here in Payson, depend on water stored in the ground for our source of drinking water. The water comes from rainfall that soaks into the ground and is stored within random cracks and fractures in the granite rock. The underground networks of water-filled cracks are known as aquifers. In some parts of the world, water sources are abundant because high levels of rain and snow provide constant replenishment to the aquifers. In the southwest part of the United States, which is primarily an arid climate, water is harder to come by. Like many other people around here, I try to conserve water. I follow the watering rules established by the water department, and I collect rainwater in this 55-gallon barrel. I use it to irrigate my tomato plants and flowers. Somehow it didn't seem to be enough, so I made it my business to find out as much as I could about our current water supply here in Payson. So I went over to the Town of Payson Water Department to see what I could find out. They've got a lot of information right as you walk in the door. Pamphlets and such on water conservation, our water system and resources, and the quality of our water. While I was there, I was lucky enough to meet up with Mike Plew, the Town of Payson's hydrologist. I told him that I was concerned about our water supply. Mike took me back to a computer where he brought up a screen with a bunch of numbers on it. As he explained it, I began to understand that this was a projection of our future water supplies and needs. Okay, Mike, what do you use all these numbers here for?
Well, all these numbers embody a lot of work that's been done over the years. Everything that the town has accumulated in water use information since 1975, including current and projected all the way out to almost 2040. With those numbers, we can plan ahead and predict where we might be from one year to the next. That's basically what we use it for, is as a planning tool.
He showed me a map with all the elements of the current Payson water system. It's an intricate network of wells, pumps, storage tanks, pipelines, water treatment facilities, and communication systems. I asked Mike what the wells look like. He said, "Come on, I'll show you one of them." We drove over to what Mike called Payson West, a well site on Payson Parkway across from Rumsey Park. This is only one of the 42 active wells in our town's water system. That is mighty good water. Then Mike took me to the water storage facility on Airport Road, where we talked about some important water topics.
We use about 2 million gallons a day, and then on a day like today where it's going to be probably pushing 100 degrees and we have higher demand, we're using about 3 million, maybe a little over 3 million gallons a day. So like these tanks behind me hold about 2 million. So we go through these tanks pretty much on an average summer day. Our water system consists of about 42 wells. So we rely on groundwater 100%, and those wells pump water up to these tanks. That's where our pressure is built up for the system down below, and the water is distributed throughout town from the tanks and the wells themselves that are hooked up.
What is the main concern of our water supply?
Being reliant and totally on groundwater is the big issue. We'd like to spread out our water portfolio so that we're not just relying on groundwater, but also we have surface water in addition to our reclaimed water recharge projects like at Green Valley Park.
I've heard a lot about this Blue Ridge. How is that going to change things?
One of the main goals for the Town of Payson and its water department is to complete what I call the water wheel. And the water wheel for us basically consists of groundwater right now and reclaimed water, or what we recharge at Green Valley Park. Blue Ridge is extremely important to complete our water resources portfolio and add that third spoke in the wheel to make it so that we aren't 100% relying on groundwater resources, and really helps us live within our means the way we really want to. When you can manage those resources together by, for instance, in a time when it's raining a lot, there's a lot of snow, it's a wet time, you got plenty of surface water. You don't use your wells then. Lets those wells recover, lets your groundwater resources recover. Blue Ridge Reservoir, CC Cragin as they call it now, having that project in and that additional water supply will ensure that we can have plenty of water for all our future needs, any build-out scenario that we might have, as a matter of fact.
Mike Blue pointed out the parts of the Blue Ridge project that were accessible by road, so we decided to drive up and take a closer look. We've been to Blue Ridge Reservoir before. It's a very nice drive up 87 through Pine and Strawberry. It takes about 45 minutes or so to get there. Once you're on top of the rim, drive about 20 miles just past Clint Wells and take Forest Road 751 to the reservoir. This road is graveled and suitable for passenger cars in most weather, but it's closed and the reservoir is not accessible in winter. The reservoir is a narrow, winding body of water that looks more like a river than a lake. You can catch rainbow, brown, or brook trout here. All are stocked by Arizona Game and Fish. Although there's no camping at the lake, Rock Creek Campground is nearby. This is one of the most beautiful places in Arizona. CC Cragin Reservoir, as it is now known, is fed by the waters of the East Clear Creek, providing a collection area for the runoff from the Little Colorado watershed. C.C. Cragin was chief engineer of the Salt River Valley Water Users Association back in the 1920s. He was an early proponent of matching the goals of an irrigation project with a hydropower generation venture. We'll see the significance of that a little later. We asked Greg Kornrump of the Salt River Project about the history of the reservoir.
It is a reservoir that was built in 1963 by Phelps Dodge. It was part of an elaborate water exchange that allowed for Phelps Dodge to take water out of the Black River for mining use in Morenci. And water from Blue Ridge Reservoir was taken over to the East Verde, put into the East Verde, and then taken down to the Verde River for storage as a payback supply for that water that Phelps Dodge took out of the Black River. The agreement that was put together gave Salt River Project a right of first refusal to acquire the facilities should Phelps Dodge no longer have a need for the water supply in the facilities. Several years ago, with passage of the San Carlos settlement, Phelps Dodge was to utilize the San Carlos tribe's CAP allocation to pay SRP back for the water that they take out of the Black River. And that left Blue Ridge Reservoir without a demand. And so it's under that provision of the agreement that SRP acquired the facilities from Phelps Dodge. The pipeline and the rest of the Blue Ridge facilities have provided great service for over 40 years. And according to the assessments that we've done, it will have many more years of service ahead of it.
SRP's acquisition of the reservoir and the passage by the U.S. Congress of Arizona Water Settlement Act in 2004 makes it possible for the town of Payson to bring 3,000 acre-feet of water per year from the reservoir to Payson. This is the surface water that will provide the third spoke in the Town of Payson's water wheel and complete its water portfolio. Phelps Dodge built the dam along with a 9-mile pipeline from the reservoir to an outlet on the upper East Verde River near the subdivision Washington Park. The entire process of delivering water from the CC Cragin to Washington Park is really quite amazing. This is the very, very interesting part of this. Somewhere on the other side of this reservoir, they have bored a 6-foot tunnel to carry the water under the mountains. Water is diverted from the reservoir through a screened inlet structured into that tunnel. The tunnel inlet, as it is called, is 6 feet in diameter and is 4,427 feet long. The tunnel ends and connects to a 435-foot deep vertical shaft that comes up on the other side of the mountains, just about 3/4 of a mile from here as the crow flies. A pipe was inserted into the shaft and connects to a pumping station. That's our next stop on this tour. Even though we are less than a mile from where we were at the Blue Ridge Reservoir, it took a little over an hour to drive here. This is the pump station that is connected to the inlet tunnel and shaft at the bottom of the reservoir. The pumping station consists of 1 submersible priming unit and 7 pumping units. The water is drawn up through the pipe by the pumps like a straw and then routed into the pipeline. The pumping station has its own power source, which we will see later. We're 6 miles out on the pipeline from that pump station. The water is pumped into this pipeline, which extends from here to the edge of the rim, then down the side of the rim to the Washington Park area. There are some more interesting points along the way. Although it's above ground here because of the extreme terrain, the pipe is buried to a depth of from 3 to 7 feet in most places. It follows the ups and downs of this terrain and eventually gains 565 feet in elevation when it reaches a priming reservoir at the highest elevation point of the system. The priming reservoir is a huge open steel tank, 130 feet in diameter and 21 feet tall, with a capacity of 2 million gallons. The open top allows helicopters to remove water for firefighting purposes. It wasn't until we got up here that we started to put things into perspective. On an average summer day, Payson uses 2 million gallons of water. That's one of these tanks per day. On summer holidays, such as the 4th of July, we use 3 million gallons, or 1.5 times what's in this tank. That's a lot of water. As this is the highest point in the system, here at the priming tank, gravity takes over and moves the water down the pipeline. Just a couple thousand yards from here is another important element of the system, what is called a surge tank. The surge tank is a buffer for the pipeline as it continues its journey to the edge and down the side of the rim. This is a pressure regulation device that prevents the water from surging in the pipeline and bursting it. Here's where the pipeline begins its 1,480-foot descent down the side of the Mogollon Rim to its eventual destination. You may have noticed along the way this electric line follows the path of the pipeline. When we get down to our next location, you're going to see why this electric line is so special. When you see these sites up close and personal, you begin to realize what an immense engineering feat it was to build this pipeline system. Back in the 60s, it cost $7.23 million to construct this project, including the reservoir, the pump station, pipeline, and the power station below. If you tried to compute the cost of doing this in today's dollars, it is mind-boggling. Considering the challenges of the terrain and the fact that many of the roads we have taken today did not exist, you have to take your hat off to the people who worked on building this project. The pipeline continues down the side of the rim and reaches a point right beside the East Verde River. What you see behind me is a power generating station. This station has a 2.3 megawatt capacity, which is ample power to run the pumps we saw up at the pumping station. And that's exactly what it does. And the source of the water that turns this generator's turbine to make the electricity is the water that comes down the pipeline. So the pump feeds the pipeline that makes the electric power down here that powers the pump up there. It's like a perpetual motion machine, and it would make C.C. Cragin proud. The pump runs 9 months out of the year, and as you can see, the tail race is side by side with the East Verde River. In fact, it feeds water into the East Verde. One of the concerns about bringing this water to Payson is the effect on the flow of the East Verde River. The flow of the East Verde River itself is on the right. The diversion into the new pipeline to Payson would not affect the natural flow of the East Verde River. In fact, Payson's portion of the flow emanating from the tail race is only about 1/6 of the maximum flow out the channel. Now that you've seen the first part of the Blue Ridge project that already exists, we'll show you how the town of Payson's future water will get to its final destination. The water flows out of the generating station and into the river. The man-made channel that it flows through is called a tail race. The new pipeline and valve will be connected right here below the tail race. The pipeline will head west for about 1/4 mile and then follow the Forest Service road to the control road and east to Whispering Pines and begin to follow the Houston Mesa Road down the hill. The pipeline route into Payson from Whispering Pines will, in general, follow the road and be constructed right beside the road. The town of Payson plans to utilize the right-of-way along the road for the purpose of building the pipeline. There are other issues, such as possibly taking the pipeline through Forest Service or private land in order to avoid some tricky terrain. An environmental study of the pipeline route is presently underway, and the town council has also authorized an environmental study to obtain clearance for purchase of the water treatment plant site. The new pipeline will bring the water to a location yet to be finalized for treatment before going into our existing water system. There are a couple sites currently under consideration for the treatment plant on Houston Mesa Road just south of the Shoe Fly ruins and at the corner of Houston Mesa Road and Highway 87 in Payson. The proposed treatment plant will be state-of-the-art. We were lucky enough to visit a similar facility in Fountain Hills to get an idea of how the treatment plant works.
The water gets pumped into the microfiltration facility and then goes through a header to each of 4 different microfiltration racks. This facility can treat 2.4 million gallons a day with the 4 microfiltration racks. The racks consist of a number of modules. The modules essentially look like columns of plastic pipe. Inside the pipe columns are the microfiltration membranes. The little straws inside the microfiltration modules are a plastic, and those plastic straw-like membranes are porous. And so the water would essentially flow in and around each of those straws and then filter through the porous membrane material, traveling out the center of the straw. The water actually flows upward through those columns and then exits the microfiltration rack at the top. From the pipe header leaving the microfiltration racks, the water is piped out to our aquifer storage and recovery wells.
Once the treatment plant is online, the water will be delivered to our current water mains by a series of new connections. I hope you enjoyed our tour of the Blue Ridge Water Project, or C.C. Cragin, as it is now known. Thanks to everyone at the Town of Payson Water Department for all the information they have given us. If you would like more information about the Blue Ridge Water Project, visit the Town of Payson Water Department or go to the Town of Payson website at www.paysonwater.com. We as citizens can help this process along by letting the town council, the water department, and the Forest Service and the state of Arizona know our feelings.
This is Planet Payson, a service of Payson Video Internet Productions.